Alright class, here we are at our second video for chapter 8 on equations and inequalities, and today we're going to be writing and graphing linear equations. Alright, so our objectives are to express the relationship between two quantities as a linear equation and to use a table or graph to represent a linear equation. So go ahead and let's write down your vocabulary words. I meant to underline all of them, but only did one. So your first one is linear equation, an algebraic equation that has a dependent and an independent variable. The variables each have an exponent of 1 and are not multiplied together. The graph of this equation is a straight line. Then you have a dependent variable, a variable whose value depends on the value of a related independent variable. And an independent variable is a variable in an equation whose value is freely chosen without considering the values of any other variable. So the first thing that we're going to do is we're going to write a linear equation for a given situation. So this says Caleb is X years old. His sister is 10 years older than he is. If his sister is Y years old, write an equation that relates their two ages. Well, we know that Caleb is X years old, and we know that his sister is 10 years older. So his sister's age in terms of X is X plus 10. So that would be his sister's age. And it says if you let his sister's age be Y years, then that would be equal to Y. So y equals x plus 10 is called a linear equation. For every given value of x, a corresponding value for y can be found. So for example, if x is equal to 6, then y would be 6 plus 10, which is 16. Alright, and in this equation, we would call x would be the independent variable, and y would be the dependent variable. Alright, the value of y depends on what the value of x is. So let's go ahead and write a linear equation for this situation. It says a rhombus has sides of length r centimeters. If the perimeter of the rhombus is p centimeters, express p in terms of r. So in other words, we're saying that P, the perimeter, is equal to R, all these R centimeters 4 times. So R plus R plus R plus R. Well, you guys already know that we can simplify that expression. We could say P is equal to 4R. So again, we would say that R in this case is our independent variable, and that P is our dependent variable, because the value of P depends on what R is. So if R is equal to, say, 2, then P is going to be equal to 8. Alright, so here's what your practice is going to look like, and then you guys are going to go ahead and try this yourselves. It says Isaiah has H baseball cards. Miguel has 7 more baseball cards than Isaiah. If Miguel has K baseball cards, express K in terms of H. State the dependent and independent variables. So first of all, we know that if we're going to write how many baseball cards Miguel has, well, he has 7 more than Isaiah, and Isaiah has H. So that would be H plus 7. And we've already said that Miguel also has K baseball cards, so we're going to say that H plus 7 is equal to K. So now I have K equals H plus 7. So I have to figure out the dependent and the independent variables. Well, in this case, H is going to be my independent variable, and K would be my dependent variable. And that was because the value of K depends on whatever H is. All right, so guided practice. There's actually going to be 4 of these, and you only have to write the directions once. It says write an equation for each of the following, then state the dependent and independent variables for each equation. I'm going to read each one aloud, but I do want you guys to try these on your own. So number 1 says Hannah took P minutes to jog around a park. Sophia took 12 minutes longer to jog around the park. If Sophia took T minutes to jog around the park, express T in terms of P. So there's 2 things we know about Sophia. We know that Sophia took 12 minutes longer than Hannah, and we also know that Sophia took T minutes. So if it's 12 minutes longer than Hannah, and Hannah took P minutes, that'd be P plus 12. And we also, like I said, know that Sophia took T minutes. So we would say T equals P plus 12. And now I just need to identify my independent and dependent variables. So in this case, P will be my independent variable, and T is my dependent variable. On to the next one. It says a bouquet of roses cost $30. A bouquet of tulips cost M dollars less. If the cost of one bouquet of tulips is N dollars, express N in terms of M. So again, we know that the bouquet of tulips is M dollars less than 30. And we also know that the bouquet of tulips is N dollars. So we're going to say N equals, and like I said, we know that it's M dollars less than 30. So we're going to say 30 minus M. And again, now I just have to decide which are my independent and dependent variables. Well, in this case, M is my independent, and N is my dependent variable. All right, let's look at number 3. It says Nathan has 7 boxes of marbles. Each box contains B marbles. If he has C marbles all together, express C in terms of B. So he has C all together, so I'm going to say C equals, and he has 7 boxes of marbles, and each one has B marbles in there. So that's going to be 7 times whatever B is. So I'm going to say that this is C is equal to 7B, and B is my independent variable, and C is my dependent variable. All right, last one. It says a motel charges John X dollars for his stay. John stayed at the motel for 12 nights. If the rate per night for a room is Y dollars, express Y in terms of X. So again, I know that Y is the rate per room, or rate per night, sorry, for a room. And they charged him X dollars for 12 nights. So if I actually take X dollars and divide those by the 12 nights, that should tell me how much he paid for each night. So I have Y equals X divided by 12. And in this case, X is my independent variable, and Y is my dependent variable. All right, the last thing we're going to do in this video is we're going to use tables or graphs to represent a linear equation. So the same thing, we just learned how to kind of write a linear equation and identify the independent and the dependent variable. Now what we're going to actually do is make a table of it and graph it. And so that might be what makes this video kind of long. So this says the length of a rectangular picture frame is 5 inches longer than its width. And if we let L represent the length and W is the width, so here's the width and here's the length. It says use the data from the table and plot the order of pairs on a coordinate plane. So again, we know that the length is 5 inches longer than the width. So basically, the length equals W plus 5. So here's what we would do is we would start throwing in values for W. Let's say that W is equal to 1. Well, if W is 1, then that means 1 plus 5 is 6, so L is equal to 6. And if we say that W is equal to 2, then that's 2 plus 5, which is 7, so L is equal to 7. And if we say that W is equal to 3, then that's 3 plus 5, so L is equal to 8. And if we say W is equal to 4, that's 4 plus 5, so L is equal to 9. If we say W is equal to 5, then that's 5 plus 5, which is 10. So L is equal to 10. And as you can see, now we've got a nice little chart going here. So what I'm going to do is I'm going to make a coordinate plane, and I'm going to plot the values onto a graph, and I may run out of room. And what that's going to do is that should show me a straight line if I have a true linear equation and that my values are all correct. I did everything correctly. Now, here's something that you have to remember. Again, your spacing, we're going everywhere. I hope that yours is written neater than mine. Now remember that your spacing for each of these has to be even. If you count by ones, keep counting by ones. If you count by twos, keep counting by twos. But also, I want your x and your y axis labeled. So down here under my x-axis, I'm going to write width. And that's measured in inches. And then along my y-axis, I'm going to write length. You do need to have your x and y axes labeled. So again, if my width is 1, I would go on my x-axis 1, but my length would be 6, so I'm going to go up 6, and I'm going to plot a point right there. And again, we said if my width was 2, I'd go over 2, but that makes my length 7, so I'm going to go up 7. And again, my graph is not going to be perfect, and yours won't be either when you're freehanding it, but I will be having graph paper in class tomorrow, so you will be able to make some pretty nice graphs. And so there's my first attempt at showing you guys a graph, and if you look, if I'd actually done it on graph paper, I would have a perfectly straight line going up my graph. Alright, so we're going to go ahead and try this again, and then you're going to try it yourself. It says, each can of paint contains 5 gallons of paint. Write an equation to relate the number of cans to the volume of paint. Let V represent the volume of paint, so volume equals, and C will represent the number of paint cans. Use the data to make a table and plot the values on a coordinate plane. So my volume equals, it says each can has 5 gallons. So for 1 can, there's 5 gallons, so that's 5 times the number of cans. So at V equals 5C. So if I go ahead and make my chart and say this is my number of cans, and this would be the volume, if I have 1 can, that's 5 gallons. If I have 2 cans, then that's 10 gallons. If I have 3 cans, it's 15 gallons. If I have 4 cans, that's 20. And if I have 5 cans, that's 25. So again, I have to plot this all on a coordinate plane with an x and a y axis. So I'm going to count by ones here. And this is my number of cans. But going up the vertical axis, instead of counting by ones, I'm going to count by 5s. And that'll kind of save me some room and maybe have my graph make more sense. But I also have to label this, so I'm going to say volume. Alright, and now I'm just going to go ahead and graph the values. So for 1 can of paint I had 5 gallons, so I'm going to plot that point. I have to go to 2 cans of paint and up to 10 gallons. And over to 3 cans of paint and up to 15. 4 cans of paint, so I go up to 20. 5 cans of paint, so I go up to 25. And then I connect all those points to show my linear equation. Alright, so now you guys go ahead and try it yourselves. You've watched me do it. So this one says, make a data table and plot the points on a coordinate plane for each of the following situations. And what I forgot to include in there is you also need to write the equation for each situation. Then make the data table, plot the points. So this one says the width of a rectangular tank is 2 meters less than its length. If the length is p meters and the width is q meters, write an equation relating p and q. And I want you to pause it and try this one for yourself. So on this one, again, I know that the width is q meters, and I also know that the width is 2 meters less than the length. So that's going to be p minus 2. Alright, so again, I'm going to go ahead and make my chart. My p's here and my q's here. And if p is equal to let's say 3, let's start with 3, then q is 1. If p is 4, then q is 2. If p is 5, then q is 3. If p is 6, then q is 4. So let's go ahead and let's plot that and get that one out there. Alright, so P is going to be my length, so and this is going to be my width. And then I would just go through and plot my points. I said if P, or the length was 3, then Q would be 1. And if it was 4, then Q would be 2. And if it was 5, then Q would be 3. And if it was 6, then Q would be 4. Mine looks wobbly, but again, if it was on graph paper, it would be a complete straight line. Alright, this one says, Paul and Lee went to the library to borrow some books. Paul borrowed 6 more books than Lee. Let X represent the number of books borrowed by Lee. Let Y represent the number of books borrowed by Paul. So we know that Paul borrowed 6 more books than Lee. And Lee borrowed X books. So then Paul had 6 more than that. So that's Y equals X plus 6. So again, I'm going to go ahead and make my chart. So if Lee got 1 book, then that means Paul got 7 books. And if Lee got 2 books, then Paul got 8 books. And if Lee got 3 books, then Paul got 9 books. And if Lee got 4 books, then Paul got 10 books. So again, I'm just going to go through and plot that on my graph. Goodness. So again, we said 1 would be at 7, 2 would be at 8, 3 would be at 9, 4 would be at 10, and again I have a nice ascending straight line on my graph, except for I'm supposed to label. So in other words, this would be the number of books That would be for Lee. And this would be number of books for Paul. Alright, last one. It says use the data in the table to plot points on a coordinate plane. Write an equation to show the relationship between the variables. So here they've given you a chart. They want you to write an equation based off of the chart and then plot the points. So let's go ahead and just plot the points first. So we have time taken in hours and distance traveled. So I'll go ahead and make this my time. I'll make this my distance. And I'm going to go ahead and count by ones here. And here I'm going to count by 50s because it looks like that's what they're doing. All right. So here it says for 1 hour they went 50 miles. In 2 hours they went 100 miles. In 3 hours they went 150 miles. So here we're just adding 50 every time, or we're doing the number of hours. 1 times 50 is 50. 2 times 50 is 100. 3 times 50 is 150. Yep. 4 times 50 would be 200. Alright, so I'm going to finish plotting these points. And like I said, now I know that the pattern here is the distance is equal to the time times 50. So distance equals 50t. Alright guys, that's it. Go ahead and write down your questions, and I'm sorry if the video went kind of long, but there was a lot of drawing. We will talk about this tomorrow. Get ready to practice.